All right, welcome back. We are COMP123, that's Programming 2, and the summer 2020 semester at Centennial. And today we're going to be talking a little bit about LINQ and list collections, and the list collection, and collections in general, but I also want to talk about, just to remind you that on Monday, I did release the next assignment. Please don't hesitate to start that one. There are small details that you're going to have to get right in order for you to be successful. So hopefully, does anyone have any questions around the assignment that I handed out on Monday? That's BMI calculator. I have a feeling there will be questions as people start to do them. So that is for that. Also, last day, and I'm just going to go back to this, we were starting this calculator example online, and the reason why I did this is because to give you a sense of how to do a table layout panel, which is what we did last day. We also created a results area, and when we start off from last day, we had some simple functionality where we can add numbers, and then we can kind of backspace and get to those. I can also clear the calculator, but one of the problems we have is when we have the dot, I only want to have one, and when I click the decimal as an example, I want to be able to have 0 dot in the decimal. If I do 8 dot, that should be okay, but I shouldn't be able to do this again. That shouldn't be allowed, right? Because this is kind of formatting the string that we need when we kind of enter data into our calculator. So that's kind of the stuff I want to cover a little bit today, how to do that. I also have a PowerPoint that I want to share with you, which is LINQ, and I want to talk about LINQ a little bit because we're going to use it when we get into data, how to connect to data with our forms. We're going to get there very soon, so I want to do all that today as well. And we're going to do it at a very high level when we talk about LINQ. And I'm going to start with this before we get into programming again. I don't want to start programming until I get into the LINQ stuff. And one more thing I want to do is talk about how to have multiple forms. We're going to start multi-form programming very soon. And I want to talk about how I can have another form, how do I link to another form, and all that kind of stuff. And a nice form for us for the calculator would be some kind of information or details or options. You know, let's say for example, I want to make my calculator do scientific calculations with more buttons. You know, as an example, I should be able to show and hide them. We can have different ways of doing that. We can use a radial button to do that. So this form would stretch and have a larger layout. As an example, there's lots of stuff we can do. We can also replace the form, and by going to another form, it may look like we're moving to a bigger layout, but actually what we're going to be doing is just going to a new form. So there's little tricks that we can do, we can talk about as well. So a few things. All right. So we've learned basic buttons and labels, and we made this last day. We made this label look like a text area, and this is good because the user can't go in there and type anything in at all, right? It prevents any entry, it's a good thing for a calculator, right? So we've restricted him that way as well. So we did a couple things. But first, I want to get into the PowerPoint stuff, and I want to talk about what LINQ is and why it's important, and maybe a little bit about collections before we get going. So, what is LINQ, and why do we need it? Well, we have, as an example, lists, and we're going to access arrays and other kind of collections. And I want you to think about us accessing a database in the future. The database is going to be very list-like. We're going to have a list of records, potentially, and sometimes we have to access that list of records and sort it or search it or whatever, filter it. And LINQ allows us to do that in a method-like fashion as opposed to using a query language like SQL. We don't want to use SQL. LINQ was developed for programmers by programmers, right? So what it is it's called Language Integrated Query, and it gives us a very simple expression that allows us to query any collection, not just lists and arrays, and databases with a very similar structure to SQL or SQL. So how does it work? I'm just going to skip down to, first of all, it's declarative. So we want what we want. We ask it for what we want, and it comes back, and we get a response. By the way, declarative programming is also something that is now being used in the very kind of new Swift UI. Declarative programming when I want to create a UI. So declarative programming is a thing that's out there. It's not something that's limited to LINQ or C#. Okay, so here's some examples. We have of values, which is a new array, and you can see that we've initialized our array with our initializer syntax as an example. And then what we want to do, one way of doing it is we can display the original values by looping through the array for every element in the values array. We want to write out the element. It's pretty simple, right? So kind of simple stuff. We can use LINQ, and by the way, when we go up here, we need to include using system.linq. But we can use LINQ to do something that looks like this, where we want to filter a list, right? So or an array. So I'm going to say we can use a few keywords here: from, where, and select, similar to what we do with SQL when you do databases. So you can say something like from value in values. So for every value in values, where the value that I'm looking for is greater than 4, select that value and then return it and store it inside of this filtered variable. Now, it could be more than one value, right? Because you're going to store a bunch of values inside this filtered collection. It's an enumerable collection that's going to be stored and filtered. It's not quite an array or a list. You're going to get another enumerable type that's in here, okay? But then what we can do is we can use a for each to loop through and write out those values. So we can filter, we can kind of make a new list or array from the array that we already had, and by using from, where, and select. So kind of a few keywords that we want to use here. Okay, so that's kind of the power of what LINQ can help us do with simple arrays. And we can also sort, so we can say from value and values, order by value, as an example, and then select that value and store each value in a sorted way inside of the sorted list or array. We can do that as well. And this is okay for simple arrays and lists. We can also do filtering and sorting. I'm not going to go through that. Sorting and filtering. And you can see that the output is where it is. So this is kind of what LINQ is really good for, and it talks about each of these clauses here in the PowerPoint. Again, I just wanted to introduce this to you so we know where to look when I ask you to use LINQ, later on. Okay, so that you have a document that helps you out, because it's something it's kind of really cool. So there's the from clause. We have the where clause where we do a match. That's what this does. It matches it. It gives us true or false as an example. Then we can select, and that determines the results. That's how it works. And order by kind of sorts it by ascending or descending, which is kind of cool. IEnumerable describes the functionality of the objects that we get back. That's what happens, right? But sometimes what we want to do is we want to convert them into to an array or to a list. Here's an example of where we have a more complicated structure. So for example, I have an employee, and employee has first name, last name, and monthly salary. Here's an example of that, right? So we have an employee class, and then we want to do is create a, so I'm going to go down here, a list or a new array of employees, a bunch of employees. So now this is a more complicated structure to loop through as opposed to a simple array. And LINQ can help us with this too, right? Because it doesn't really matter as long as it's a collection then LINQ can do is something like this. So I want to get employees that make a certain salary between 4K and 6K as an example. So they have a salary range. Maybe this is per month, monthly salary, 4K and 6K. And you can do that. You can say from employee in employees where the employee's monthly salary is greater than 4,000 and less than 6,000, right? Then select that employee. And M is in terms of currency, right? So select that employee and return each of the employees and store them in this variable called between 4K and 6K, this one. And then it's as simple as looping through each of those things, that new collection, and writing out all of those elements. So that's kind of what that can do for us. We can also sort it like normal, and we can sort it by last name. So I want to select only the last name for every employee and employees. E is, let's say, employee. For every employee and employees, select the employee last name and store only last names in there. So that's really good. We can kind of filter through the class or the objects, each of the objects that we have inside the collection, and then we can just print out last names, which is kind of really cool. So again, really powerful in terms of what LINQ can do for us. And we can also create objects that have, notice the new first name and last name. We can create new objects that have first names and last names, and then we can do that as well. So very interesting, and what it can do for you is pretty powerful in terms of selecting. So that is what LINQ can do. You can also use the AND case for that, just like we normally can. I'm just going to skip down to where it really matters as we get into this. So that's what LINQ is. I'm just going to go through here. You can also create new types inside of there, and that is pretty good. I think that covers everything I want to talk about with LINQ. Okay, so all right, so then you've already talked about things like lists and in the past, and arrays as an example. So I just wanted to review some of this stuff because we're going to be dealing with lists and arrays over the next little while. And again, we're going to do it because we're going to have a list of, for example, special objects, a list of potentially students or employees or whatever we're going to have, right? And notice the T that's in here specifies something called a generic. So this is like a generic collection. Collections are generics, and generics mean that this T stands for type. You can put whatever type you want inside the list, including your own custom types, like an employee class or a student class or whatever. All right, so that's kind of how lists work. Same thing with sorted lists. Sorted lists have key value pairs. And this is the new way. This is the old way of doing things. There's something called an array list. Now it's just called a list in modern .NET. And there's also something called queues and stacks. As an example, notice they're also a generic. Again, this is just a review. You guys should know about some kind of collections. You should have been kind of learn about collections last semester or this semester already. I'm just talking about this because if we have the list collection, right? List collections have a bunch of different kinds of methods that are attached to them. For example, things like clear and add and so on. And we're going to be dealing with list collections because whenever we have some kind of pull down inside of our user interface, then we're going to maybe make it a list, right, or something. And I want to add and remove things from the interface. I can do that by adding and removing things from a list. Right, so that's what they are. Well, that's what the pull downs are, almost like a pull down menu. We'll talk about those later on. May not be today, but we will. And so there's different kinds of methods that all lists have. Okay, so that's what one thing to notice. And I wanted to give you this PowerPoint again, so you have access to this kind of stuff in one place where you can kind of access a lot of these methods. You don't have to look it up anywhere else. They're right here. And on a test or something like that, if I was going to test you and give you some kind of true, false, multiple choice tests, I'm not planning to do that, but if I was going to, this would be like the single place where you can go and take a look at all that stuff. So it talks about a lot of different things here, but where I want to get to is because lists, remember we just talked about LINQ, And you can add and remove items. It talks about, it demonstrates here in this PowerPoint how to do all that kind of stuff, which I'm not going to go over because you guys should know about collections already. I just wanted to give you some, kind of an update. So there we can add things to the list, but now we want to use LINQ to access this list, custom lists of different values, as you can see. And what we can do is we can use LINQ with this. We can say something like from item in items, where items is a list of different colors, it looks like. And each of the colors, notice that they have, they've been entered in a weird way. We have different letters inside of these colors that are capitalized, as an example. And we want to fix this problem. We don't want this to happen. So what you can do is you can say, you can create a new variable inside of your LINQ selection criteria. So you can say something like from item in items. This is like a for each loop. That's what this from in is, right? For every item in items, that's what it is. Then I'm going to make a new temporary variable, uppercase string, is equal to the item dot to upper. So it takes the item, makes it all uppercase, and then what we want to say is where the uppercase string, this new variable, starts with, remember, because starts with is part of the strings. You can search strings in different ways. We're going to use a search criteria today when we search for decimal. Starts with R. When it starts with R, then order by the uppercase string, right? So we're filtering, we're only looking for strings that start with R, and then select that uppercase string, and we're going to store it here. So that's interesting. We're going to do that. But we're first modifying the thing we get from the items and storing it in there. So there's lots of power that you can use. Like LINQ is amazing when it comes to sorting and even searching. You can use it for searching criteria. And what happens is, again, LINQ does not return an actual list or an array. What we need to do sometimes is we need to convert it. We have to convert by using the toArray or toList methods that are built into LINQ. So these two methods, toArray and toList, are very useful because it actually converts whatever we have that LINQ kind of returns into an actual array or list that are compatible. So we can use all the array and list methods that we get back out of LINQ. So that is LINQ in a nutshell. Okay, LINQ. So language integrated query, which is very powerful, and again, made for programmers by programmers because they were getting tired of the wordy way we were kind of looking at collections and other ways of doing things. By the way, LINQ can also be used as almost like using methods, and we'll show that as well. But it's quite interesting what you can do with LINQ. And we're going to be using LINQ over the next couple of weeks, because as we continue to do more and more with user interfaces, we're going to delve more into data, and this is a great way. I'm going to refer back to this week 9b, where we talk about LINQ and list collections. All right, any questions around LINQ? I think it's kind of interesting. It's another tool in our toolbox. That's what I wanted to share with you before we get into something that looks like this. All right, so this is cool. So what we had in my calculator form, going back to my calculator from last day, is we had some basic conditional statements. So first of all, as a reminder, a review of what we did last day, we had this shared event handler. So that's what this is. And let's use the // to do some documentation. So // Here we can create a doc string for this one. We can say that this method, or we can say this is a shared event handler. For all buttons on the calculator, because that's what it is, right? So that's what it is. So it takes all the buttons, and then what we did last day is we said, okay, well, we want to create a temporary item anytime this calculator button click is invoked or triggered, right? Remember, this happens asynchronously. This is an event, and events, it's almost like I'm doing something like this. I'm listening for an event to be triggered. So in my interface, when I run this thing, I'm constantly listening for buttons to be clicked all the time. Okay? It doesn't stop. I don't stop listening because I've linked all of these buttons into the same event. And again, if I click any one of these buttons, remember that there is in the properties, there's a few buttons here. One of them is this little lightning bolt. And the lightning bolt basically indicates which event or event handler is linked with this stuff, right? That's what this does. Every one of them is linked to the same event handler, which is calculator button click. And so their calculator button click is actually listening for any button click. So what we do is we create a temporary button called calculator button. So this is not something that we display. We make an object in memory, all right? So we create a button object in memory from the sender object. So what happens is the sender object is basically gives us information about which button was selected, which button was clicked. That's what this does, all right? So the sender object is full of information, but it's a generic object. Remember we talked about the object super duper class, right? And the generic object doesn't know anything about buttons. It's not a button, it's just a generic object. So it has some generic methods. But what we want to do is cast the sender as a button, which is what this part is right here. This makes it seem like the sender is a button. And then we make a reference to the sender as calculator button. So how do I explain this part? Because people, when you do this kind of thing, you get kind of lost. You're like, wait, I don't get this. How do you cast one thing as something else? Well, let's draw it in a kind of way like this. Okay, so imagine if all objects were this square, right? So I've got this square object, right? But this object is almost like a pointer, right? So I have, this object points to something else, all right? So, here we have, it's pointing to the button, right? It doesn't know that it's pointing to a button. It just knows that it's an object, some kind of object. We don't know what it is. The object is so generic that it doesn't know. I mean, it could be pointing at any of the objects in C#, anything. That's what this thing does. Almost like any. Think about object as any, and it's pointing at some button, right? But it doesn't know it's pointing at a button. All it knows, as an example, right? All it knows is that it's pointing at some other object. This object variable, if you will, a container. So let's say, for example, it's pointing at a button, right? So there's my button, right? It doesn't know though, right? So we want to tell it that the actual shape of this object is not a regular object. It's actually the shape of a button. And so even though it might have additional properties, right, this object doesn't know about them. It doesn't know about them because basically object is the superclass of all other objects, right? So button is an object, right? It is an object. But what we want to do is we want to tell this object that we're getting in, which is a special type of object. It's the sender object, right? That's what it is. We want to tell the sender object that it actually is a button, because the sender could be any object. It could be a label. It could be anything else that we click on, right? We want to tell it that it's a button. Once we tell it that it's a button, now it understands that it has additional methods and properties that a button would have. Otherwise, it wouldn't know. It's just a generic object. And a generic object only has a few methods. ToString, right, is one of the methods that all objects have, and so on. And let's test that out. If we go to, as an example, back to here, and if I was just going to make this sender, you can see that I can do something like sender dot, and then these are the 4 methods that all objects have, because it's an object, right? Even if I make a new object, if I say object my object, right? Okay, if I do something like this, and if I hover over my object, right, unless I say it's a new object is equal to a new object, you can do this, right? Because object is the superclass of all other classes, right? The object class. Then I can do something like my object dot, and you can see that these are the things, these are the methods that I have: toString, get type, get hash code, and equals. Those are all the methods that all objects have. And so because we're saying that sender is an object, which is true, it's an object, but it's a more complex object. It's just that sender, when it comes into this event handler, doesn't know that it's a button. It has no idea, right? So we have to tell it, and we tell it by doing this, right? And once we've told sender that it's a button, once we cast it with the as keyword, then you can see that calculator button dot. You can see that there's a bunch of other things. Remember that big long list of things that buttons have? Look at that. There's like a ton of things that buttons can do, because buttons are a UI. You can actually look and see what a button is, right? So if I click on button as an example, right, that's the button class, right? And I want to be able to get information about the button class. Again, I can press F1. If I press F1, I actually get information from Microsoft about the button class. So I hover over the button class, press F1, and then here's my button class. That's what pops up in a browser. So this is what the button class is, and so on. And you can see that the namespace is System Windows Form, right? As an example, it talks about the inheritance chain. Object is the superclass, marshaled by reference object, then component, then control, then button base, then button. So you can see there's a long chain of kind of class hierarchy before we get to the button class, right? So that is kind of, we do that. That's how we get that. And if I click on F12, then it's going to take me to the button. So this is System Windows Forms. I can actually go to the actual button definition if I press F12, right? And you can expand that, and you can actually inspect what the button looks like. Notice that it inherits from button base, and it comes from this iButton control. It implements iButton control interface, right? This kind of thing. So you can see that there is a public constructor, an empty constructor, plus a bunch of other kinds of things that it can do. These are all the different kinds of methods, and there's many, many, many other things that it can do. But that is a way of getting to the button class. And you can't modify this, it's locked. It's not like I can go here and kind of type in my own, make my own button. It wouldn't accept that, but you can inspect it. You can inspect any class that's in here. So if I said, well, I want to look at what event args is. I don't know what that event args class is. I press F12, as an example, and it's going to take me to event args, and it's going to talk about where what is event args, and we can kind of look and see what that is, and what is event args. And you can see that this is the class. Event args looks like it's pretty empty, like there's nothing in event args for the most part. It says represents the base class for classes that contain event data and provides a value to use for the events that do not include event data. So almost like a container class is what this is used for, which is kind of interesting, right? Again, you can see that you can do that for any classes that you want that are in here. Okay, same thing with form. If I want to look at the form class, F12, right now I'm looking at the form class, and these are all the properties of the form class that we've seen before in the map, right? So kind of interesting way. So going back to that then, button has a lot of functionality, and sender is a button because that's the one I clicked. But we need to tell sender that it is a button, and that's what we did here. Okay, we need to tell sender that it's a button. Once we do that, then it has tags, and we can do a bunch of other stuff to kind of filter it. And that's what we've done here. We've kind of said, okay, if we've made some custom tags, and I did that inside of the design view. So inside the design view, there is a property that we can use called tag. And what I've done is separated all the green buttons as operators and all the blue buttons, right, as an example, as operands. That's what they're called, right? Operators and operands. And I've done that with the tag. So then I can say, okay, fine, if the tag is a operand, then do something else. Else, if the tag is an operator, then do something else. And if I got some other weird tag, well, then I'm not going to do anything. I'm not going to, if I click somewhere else, if the sender is something else I'm clicking on by accident, well, if I haven't labeled it, it's not going to really give me anything else other than these two options. So if I'm looking at the operand now, I want to, what happens if my operand that I'm clicking on is a dot? So that's what I want to look at, or a decimal. So first of all, there's a couple scenarios here. If my result label.text is already a 0, and then I click a dot, I want to append my decimal to the result text. That's what I want to do, right? So when I click my calculator, again, I run my calculator, I don't want to be able to just replace it with a dot. I want it to say 0 dot if it's already starting with 0. Okay, so that's kind of something that I want to do. All right, so it depends on if the result label text is already 0. And I also want to know when I've already clicked on the decimal. I want to click on the decimal. I want to know that I've clicked on the decimal, and I want to keep track of that. So I can do that by keeping track of if the decimal has been clicked, as an example, already, or been used, or if it already contains the string that I have, the result label.text string contains a decimal. If it contains a decimal already, I don't want to add another decimal. All right, so that's when something I don't want to do. Right, so there's two cases here. One, I'm selecting a decimal, and two, if I already have my result label.text as 0, right, as an example, then I may have to test for this a couple of times, right? And what if the decimal, I select the decimal, and as an example, my result label.text is not 0, right? So that's something else that I have to do. So first, let's make that case. So I'm going to say that, well, let's do it out here, and then we'll talk about how to refactor some of this. So if, as an example, my calculator button, and this is the calculator button.text. So calculator button, we know it's an operand. We know it's an operand, right? So we know it's one of the blue buttons that we're clicking, right? And we're specifically looking for the decimal, right? So if the calculator button.text, right, example, is equal to the decimal, that's the one we want to look at, right? Then what we want to do is, if the result label.text already contains a decimal, do I even want to look for this thing? If it doesn't contain this, then I don't even want to think about this if it already contains something. I don't care about doing my if statement and doing whatever if it contains. So what I can say is, let's do it. Think if result label, we can do it a couple different ways. Result label.text contains a decimal, right? If that's true, that's going to say, okay, it's true. Then we don't want to do this, right? So we want to say if it doesn't, if result label.text does not contain the decimal, then we'll start checking to see if it's the button that's been pressed. If the button's been pressed, as an example, if calculator button.text is a decimal, and if the result label does not already contain a decimal, because if it already contains a decimal, that would be bad, right? We're searching for this string, and we're saying, does it contain? That's what contains does. Contains is a string method that looks inside the string itself and returns true if it contains whatever I'm asking for. It doesn't tell me where. It just gives me a Boolean, true or false. Does it contain? We don't care about the index, where it contains. We just care about that it contains a decimal, right? So if it doesn't, then we want to add it, append it, to the result label. So we can say result label, right? We want to plus dot text, right? Plus equal to the decimal, right? The calculator button dot text. Now notice we're duplicating, right? We're saying result label is equal to calculator button dot text over and over again, right? But it's different. it's different in every place, in every instance. So we're going to kind of think about, can I take this and then somehow, put it inside of, when the result is 0. So can we combine some of this stuff so we don't have all of this, okay? And we're going to talk about refactoring in a bit. I just want to make it work first, and then let's see how it goes. So then, again, I'm checking to see if it already contains. So let's see that happening. So right now it doesn't contain, so if I press dot, I'm pretty good. But if I press dot again, oh man, what happened? I thought it was supposed to say that, well, if it contains, it does contain a decimal. I was looking for a decimal. It does contain it, so what the heck? How can I keep doing this over and over again? It does contain, right? Result label.text. If it does not contain, then we add it, right? We add it on, right? So the trick is this even firing? Is this thing here even triggering, right? Because remember, we have a series of if statements, right? And every one of these can be something that we're adding. So here's an example. If result label.text is equal to 0, then this, but if not, then do this. And this adds it anyway, right? Here we check afterwards, but it's too late, right? It's too late. So we want to combine this, right, with this somehow. So we want to take this part, and we want to put it in here. And we want to say something, if the result label contains this, does not contain this, and if this is true, as an example, so if it does not contain, then it's okay to add it. If it does contain, well, then don't bother adding it, as an example, if it happens to be this, right? We can also do it a different way. We can say that, well, if it's the dot that I'm adding, right, because this is a special case, right, we can do it the other way around. I can say that, okay, cool. If it's the dot that I'm adding, right, check to see if it already contains it, right? If it doesn't contain it, then you can do it. All right? If it's the dot that I'm adding. So it's almost like a check to see if this is being added, and then you can add it, otherwise don't. Else, we can say if it's anything else other than that, any other kind of things, then just add it. Okay, so that's another way we can reformat our little if statement and rejig it a little bit. So check to see if it's a dot. If it is the dot that's being pressed, hey, does the text already contain a dot? Well, if it doesn't, then add it, right? If not, don't do anything, right? Because that's what it would do. It was not. There's no else, which means it's not going to add something in there. So now this should be able to guard our results. Let's try this out. So again, I go dot. You see, I can add one, but if I click it again, I can't add one. I can't add another one, right? It doesn't allow me to do that kind of stuff. It only allows me to add the dot once, which is what we want, because otherwise we have more than one decimal place, and we try and convert this number later, which is our scope. We want to try and do that for a calculator. Then it's going to come up with an error. All right, so that is if the result text box, as an example, is not 0. Okay, well, what if the result text box is 0 and we want to press this? Now we have another case again. The same case, right? Well, what if it's this case? I don't want to, and this is another thing. If the result text box is not 0, so if it's not 0, right? So here it's not 0. Here it's 0. I'm already 0, right? But here it's not 0. It's something else, as an example, right? Then what I want to do is I want to, and I press a dot, I'm going to append it, right? This is the case we're doing here. So if I just press, if I have a 9, then I want to append. But what happens when it's 0? I don't want to do this, right? Because this will replace the 0 with my decimal. So it's almost like I want to do this again, right? Okay, now we're duplicating, and when we duplicate, there's always a better way of getting this done. So I'm saying, okay, cool. If the result text is 0 and my button that I'm listening for is the dot, and I don't already contain the dot, well, guess what? I can't already contain the dot if my result text box label, my result label is 0 already. So this check is unnecessary. We don't care about this check, right? Because you'll never have a result label that is, as an example, that is, already contains dot, because right now it is 0, right? So if it's true, then I want to add. Otherwise, just replace. That's what this is talking about. So if it's 0 and I press a dot, then I want to add. Otherwise, if it's not a dot that I'm pressing and it's 0, then I want to replace the 0 with something else. That's what I want to do. Okay. Again, there is some duplication here, and we're going to go back and fix this up again, but let's try this out. So here, as an example, we're running it, and if I press dot, you can see now, oh man, what happened? Calculator, I said plus equals if the result label.text is equal to 0, and if my calculator button.text is equal to dot, then I should be adding, not replacing, right? So can't add extra zeros, but somehow my result label.text equals 0 does not trigger, right? So that's interesting. So it's like I want to do this, but this is happening anyway, right? So what I want to do, of course, is I want to say else. So else would be here. Okay. Result label.text is equal to 0. And then now this is a very specific case where I'm going to say something like, hey, result label.text is one of these two things. But the only difference is that we have a plus equals and an equals. If I had them both as equals, I can use the ternary operator here because one is plus equals and the other one's equals. Can't do it, right? I can't do it. So, so this has to stay like this, unfortunately. And let's run this again. And again, if I press dot now, it adds it on as opposed to replaces. Now, okay, what about subtraction? So if I go back, and if I press this and I press this again, okay, I can't do this. I press dot, no problem. Let's try some cases where I can, add this in. What happens is an example. If I go dot 0.3, but then I backspace. If I remove the backspace, I'm back to the dot, 0 dot. What does that mean, 0 dot, right? Can I add 0 dot together? If I add 0 dot with something else, what happens when I click this 0 dot? As an example, should it be 0.0? As an example, what happens with this? And sometimes what people would want to do is, if I get to 0.3 and then I remove 3, I also remove the dot, right? Okay, so it really depends on this, because this is going to be a case where we're going to have 0 dot and we're going to try and add it to something else, and it's going to not compute because 0 dot doesn't compute, right? So I'm just letting you know about this case. So far we've been able to stop this from happening with a few if statements, okay? Not the cleanest code, that's for sure, right? Because we are checking for this once and we're checking for this twice, right? So a couple of cases where we're checking for this. There's two different cases though. If the result labeled text is equal to 0 and the calculator button.text is equal to dot, all right? And then think about this. Else if the calculator button.text is equal to dot, right, by itself, right? Well, there's some refactoring we could probably do here to rejig this thing. And we're going to come back to this later. Right now, it works. And I'm not going to do refactor. Remember, we make it work first, and then we come back and refactor after, because it can take some time to think about how to use Boolean algebra to come up with a better scenario here, okay? Okay, so that's the first part. So the first part is, we've got our input. It looks like we have pretty good input now when we run the calculator. I can get some basic numbers, right? And I can make a pretty big number actually that looks like this. And we shouldn't be able to go beyond that. I mean, I can kind of make it keep going, right? You can see that it's a big number, and this could be a bigger number than we're able to hold here, right? As an example. So the thing that we want to make sure is that we make it a double, okay? A double precision. Because this can be pretty big from a precision perspective, right? So we want to make it a double or a decimal, one of the two. Making it a float, which is a single precision decimal, might not be the right choice. And what if we go further? I can go beyond. I can keep typing and it's not going to show me anything else. So we can adjust for this. If I want to make a really big number, we got to be careful though, because we have to have limits. We have to have limits in terms of how big we can enter it. But let's assume that the user, for now, we're just going to make a very simple case first, where the user's not going to enter all these numbers. We're going to fix this later. Right? First, I want to make it so that I can do some of these functions. Oh, that was interesting. Sorry. So that was something else. I went da-da-da-da-da, and I went really, really small, right? And then when I press clear, and now it's small again. That's not good. So when I clear it, it's got to go back to its original size, which is like 40. Okay, I didn't do that. So let's fix that. That is something we can fix automatically. So again, it says like, okay, if my is greater than 7, and this is if, you know, again, if I've clicked an operand, and if it's greater than 7, well, you know, this is what's going to happen if I click this. But I have to check to see when when I'm clearing that I sit back and I come to this as well. I'm going to do this again. So another bit of duplication. And I'm going to do that down here in the operator. When I click the clear button, in case the clear button is clicked, my result label.txt is equal to this, and I'm going to change my result label font to 40 again. Okay, so that's something that I want to do when I clear. Okay, so again, I can do that there. And again, if I do that, so I have a big number, you know, as an example, really, really big number, and that shouldn't be allowed. But let's suppose I have this really big number, and then I click clear, then I'm going to go back to the regular 0 again. Okay, so a couple things. But now we've put some functionality back into our calculator. And what I want to do is I want to put this up on GitHub because, you know, I've added functionality. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. You can see that I've made changes to the calculator form. And I'm going to say filtered the decimal operand. That's what I kind of did. And I fixed also the font when I clear. I'm going to just put this as a thing. I mean, I could have made multiple commits here. Commit all, save, home, sync, and push. That should push everything up onto GitHub, so you can have my code now if you're behind. Okay, so kind of straightforward when it comes to this kind of stuff. Questions so far about what I'm doing with the code base. So again, first things first, just a review again one more time, step back and slow down. First things first, make your UI, your user interface. And it doesn't matter if you're programming for Android or iOS, or here we're using Windows Forms, you need to make your UI first. No code. Then use the code behind file or the controller. In different languages and different platforms, you may have something called a controller, which is just a class that has your logic, right? This is the logic in the controller. And the logic behind the user interface, this code behind file in this case, right, is something that we're going to code. And I'm just coding this one calculator button click event. That's all I'm doing. There's no other events here, just this one event, all right? And again, I'm going through and I've got two parts. One, if the event is of type, if the calculator button that's been pressed, as an example, is an operand, or if the calculator button is a operator. Okay, that's what the two things are. Now, it's a pretty big long piece of code, and sometimes what we want to do here is we want to use something called operand. You know, kind of, I want to handle the operand, right? As an example, I want to handle the operator. I want to handle the operator and the operand separately. And I can do that by extracting a method for this to make it very simple. So I can say, hey, let's select all of this stuff up to here, right? And I want to right click and I want to refactor this stuff out, right? So I want to extract is what I want to do. I want to extract this stuff out. And if you don't have, I'm not using ReSharper right now, right? So again, you can see that there's limitations on what I can do right now, right? I have outlining, I can hide the selection, I can put it on source control, I can do a bunch of stuff. But one thing I can't do is I can't really refactor by default, right? If I go to here, I can go to refactor here and I can extract method. So that's in the edit menu, right? Extract method. This is kind of interesting. If I click extract method, then it's going to say, okay, cool, there's a new method. What do you want to call this method? We're going to say handle, this is the operand. So handle operand, all right? Okay, or because that's what we're doing. We're handling the operand input, or get operand input, or something like that. Could be another thing we can call. We can say something like, you know, get operand input, or filter operand input, because that's what we're doing. We're kind of filtering the input. That's the first part. Actually, that's maybe the best name, right? So filter operand input, okay? And when I do that, now I have another method called filter operand input that's only about the operand, only about the number buttons and all those kind of things in the decimal. Okay, so that's what this part does. And now when we look at calculator button click, it's a little bit easier to read, okay? Because I'm kind of partitioning a little bit. And we can do the same thing for the operator. We want to kind of compute, we want to do something with the operator now, right? We want to, in the operator part, we want to handle the operator, or we want to, you know, kind of apply the operator to the operand. That's what we want to try and do, right? Whatever the operand, if there's an operand already, we want to apply the operator functionality, right? And we want to do this operator functionality over and over again. So for example, in our calculator, our classic calculator, I can do something that looks like this. I can say 7 plus, notice that there's a plus up here. We don't care about showing this, but 7 plus 7, okay, I've added 7 to 7, and then I press equals, and I have 14. And if I press plus again, now 14 is the new operand, and then I add, let's say, 7 again, and I press equals, now it's 21. And the other functionality that this has, if I keep pressing equals, it's going to keep on adding 7, the last operand, onto my result, right? So I keep on adding that forever if I just keep pressing equals, right? If I keep pressing plus, it doesn't do anything, but I can kind of do this. I can kind of add plus and equals over and over again, where I'm adding the plus over and over again. That's just kind of interesting. I don't care about the commas right now, but we can use those later. But does that make sense? So we can actually do this. We can actually, you know, kind of add, do some functionality just with plus, right? So let me show you that again. So again, if I said 2 plus 2, and if I press equal, 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 it's going to keep on doing 2 plus 2 forever. I can also do chained operands, operators. So I can do 2 plus 3 minus 5 times 8 divided by 2 is equal to. And you can have some kind of result. In this case, it just ended up being 0, right? Let's try that again. 2 plus 3 times 9 divided by 3 is equal to 15, right? We can do that, and it'll preserve order of operations. So that's another thing we have to do. We have to kind of add all the operands together, right? And as I'm adding them up, start doing some calculations, right? So for example, 2 plus 3, but then I press times 9. So now I got to do order of operations on 3 times 9. That takes precedence over adding it to 2, right? It's not 2 plus 3 and then times 9, right? It's not like 5 times 9. It's 3 times 9 plus 2, right? That's the order of operations. So let's try that out. So if I did that 2 plus 3, right, times, see, it says 5 automatically, right? It kind of calculates this, and it doesn't do order of operations. Times 9 equals to 45, and where you would think that 3 times 9 is 27 plus 2 is 29, right? So be careful how this looks. This is deceiving up here. This is not the way it is. It's more like 2 plus 3 in brackets times 9, right? 5 times 9. Okay, so that's what this does. So we can do it in a chained fashion. 2 plus 3, we make a calculation. We know that 2 plus 3 is 5 times 9, right, is equal to 45. Divided by 2 is equal to 22.5, right? And sometimes we're going to get a decimal when I divide it by something, right? Other times they're going to get an integer. So we have to we're also going to get this kind of result we're going to have to deal with when we do our calculations. I'm bringing this to you because it's going to be something we have to deal with when we start doing our operator, we're going to apply the operator. That's what we're going to do. Apply operator to operand is what this really is. And what if there's no operand? That's another thing. So if I have my calculator, and let's say I have a 0, and then if I just press plus, 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 right, or minus, 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 what do these do, right? It doesn't do anything, actually, right? Actually, if you go 0 divided by 0, and then you go equals, that can be an issue. Result is undefined. You definitely want to deal with that possibility, right? So even when there's nothing, there's actually something, right? So that's something else we have to think about, in terms of, doing the calculator. Again, these are things that when you build a calculator for the first time from scratch, you're going to say, wow, calculator, it's not as easy as how kind of I thought to do, right? And again, I'm not using any kind of resolve, or I'm not going to do some kind of, a string that, kind of calculates for me. I'm not going to take the whole string and calculate the result. I'm not doing that. I'm doing, a calculator from scratch. So let's name this thing. So again, I'm going to do the same thing. I'm going to go here. I can't right-click and, kind of refactor here. It doesn't allow me to do that with the basic Visual Studio. But what I can do is I can go to Edit, and I can go Refactor and an extract method. And the method that we're going to extract is going to be like, we're going to apply the operator, to operands. So apply operator, right? That's what we're going to do. We're going to apply the operator. We can also, compute result by applying the operator or whatever. But I'm just going to actually call it apply operator. So now we have two methods, apply operator and filter operand input, right? And that's what it looks like here. So now our calculator button click is much cleaner because it's easier for us to deal with. We don't have to think about if it's an operand or if it's an operator. I have two methods for that, right? So here it's just an operator, and here we're dealing with some operand input, right? Notice what happens is when we do when we pass in this thing, we have a method. Both methods get this reference to the calculator button itself. All right, so we pass in the calculator button when we filter between operand and operator, and we pass it into each of the methods. So that's something that happens. Cool. So now that we have this, and we have our clear button and our backspace button as an example, what I want to do is I want to do a simple addition. Okay, so I want to add. But how do I add? So in math, as an example, I have 1 plus 1, right? So let's say plus comes after, but plus is actually a function. So it's like I'm doing something that looks like this. If I was going to type it out, as an example, when I'm actually doing addition, when I say 1 plus 1, that's really like saying, add 1 and 1. That's what kind of it's like, right? So that's what 1 plus 1 is. 1 plus 1, it says like take the add method and add 1 to it. Okay, that's what it does. And I got to store what's coming out of this when I do the plus, right, in here. And the thing to note is that there are two operands. So here's an operand, right? So there's an operand, and the operand is this thing. I know this is not really exciting, but bear with me, guys, while I go through this with you, because when it comes to calculations, this is an operand, right? And so is this. These are operands, right? Both these two things are operands, and the operator's in the middle, right? Which is kind of how we use a calculator. We use a calculator by saying, hey, take these two operands, operand 1 and operand 2, right? These two operands, and then apply this plus to it. Okay, but that's not how we enter things. We say, here, let's get operand 1, and then we're gonna click a method that I want to turn on. I want to turn on addition. Okay, cool. And then I'm waiting for operand 2 to come into place. How do I get the second operand after I press the addition button? right? And it's almost as if, I want to take the result, whatever that number is, I want to convert it, right? First of all, when I take operand 1, I want to convert what this is, right? We need to convert this thing, we need to convert it into from a string to whatever it's going to be, an integer, as an example. This is operand number 1. It could be a float or a double. We need to convert it first. And then, okay, I'm going to call plus. So what I'm going to say is, okay, add, this is pretty cool. I'm doing a plus operation. This is the operation I'm doing, right? And then I'm getting the second operand. As soon as I get the second operand number 2 that comes into place, after I've pressed the add button, right, I want to take this second operand and I want to convert it again, whatever that is. And then I'm doing the calculation already. I haven't done the calculation though until, as an example, so here, as an example, did I do the calculation yet? So I did 1 plus 1, but I could backspace and change the 1 into a 9 and then press equals, right? I could do that. So that's something we have to think about. 1 plus 1 and then backspace. Or, what if I just press equals? Then it does the calculation. Or, here's the other option, 1 plus 1, and then I click some other operand, right? Operator. I mean, any other operator here, not this one, but any one of these ones. And then if I click something else, like times, then it calculates too. So any other operator other than the backspace or the clear, and it will calculate. It'll automatically calculate what I have. And it's almost like I want to turn on a state. I want to say that when I click on an operator, I'm in the process of doing this operation. I'm not quite finished yet, but I want to do that operation, okay? And I want to be almost like I'm waiting. I'm in a waiting state. I'm in a state, different kinds of states. I'm in a state where my operator, I'm in an operation. I'm doing an operation, whatever the operation is. I'm kind of, finishing off my expression, if you will, right? So, not there. So any suggestions from you guys, without me boring you, any suggestions about how to deal with this? How do you think you can approach this problem? Because this is a problem, right? We're going to get different cases, right? And as soon as anything else happens, if I don't click a clear button or a backspace, if it's any other case, right? As an example, we know it's an operator. It's an operation that I want to do, okay? And if it's any operation, right? I want to trigger that I'm going to wait for these two operands. I'm going to store whatever the result label.txt is, right? So again, we can say that, remember that cases also have something called a default, right? Default is like else. So if, else, else. That's what the default is, right? And the default case says that, well, if it's not a clear button, or if it's not a backspace button, and if it's something else and it's an operator, then I want to try and convert my first operator into my first operand, as an example, into a string. But what if it's the second operand? Remember, I can have two cases, right? The case one, where if I'm pressing my calculator again, I know this is really exciting for you guys, but I mean, this could be something that I give you later on. So let's suppose I say something like, okay, I pressed my first operand. This is my first operand. Then I press the plus button. Okay, now, when I press the plus button, I'm in here. I'm in this default case, right? I'm not clear button and I'm not backspace button. I'm in the plus button. Okay, cool. I've just pressed this case and I press the plus button. Okay, I only have one operand that I've triggered, but I could have two. I could have another one. If I press the second operand, so let's say, for example, I go operand number 2, let's say 5, right? Once I press 5, I'm filtering the operand input. Now I'm waiting for my completion. My completion could be an equal sign. It could be a plus. It could be a minus. It could be a multiply. Whatever it is, if I have the second operand, if I've already pressed the second operand, whatever I've chosen, I want to complete the last operation that I've entered, which is the active operation is going to be the one that I want to complete, whatever that active operation is. Okay, the active operation. So that's something I want to keep track of. What is the active operation I want to do, right? Okay. So the first thing is, let's store some variables. And again, we can store them in my calculator form as properties. All right, so here we're going to say, we're going to have a couple of properties. I'm going to use the prop keyword for this. And one of the properties is going to be, I'm going to make it a double, right? Because it could be as big as a double, right? We could make it later on something else, like some kind of operand, special, a special case where the operand is something else, okay? Where it can be any, whatever we enter. But we'll make it a double for now. And we'll call this operand 1. Okay, there's operand 1. Okay? And we could do prop, where we want to do another double, which is operand 2. So we have operand 1 and operand 2. We can only ever have 2 operands in this case, right? Operand 1, operand 2. And what we're going to say is, okay, cool. As soon as we enter this part, if operand 2, and we're going to say that these things, operand 1 and operand 2, by default, when we start the calculator form, operand 1 and operand 2 are going to be reset. They're going to reset to 0, right? So we may want to have a reset button, which is the clear. The clear function resets operand 1 and operand 2 to 0, and also resets the clear button as an example with the display so that the result looks like 0. So going back to here, where we have our clear, this clear result label, the clear button, makes sure that operand 1, right, as an example, is equal to 0.0, right? And operand 2 also starts at 0.0 if we press the clear button. Okay? But this looks to me like some kind of reset, like calculator reset, and we want to kind of copy this. So I want to extract here as well. I want to refactor and extract the method, and I want to call this reset calculator. Okay, reset calculator. When the clear button is pressed, we want to reset the calculator. Okay, here's my reset calculator function, and that also means that when the calculator loads the first time, I want to reset the calculator to make sure that it's what it's going to be, just in case there was something else. So when I click the clear button, the calculator has been reset. So let's double click on the actual form itself. So double click on the form, which creates this form event. When the calculator loads, I want to also call the reset calculator function. I want to call the reset calculator function. These are, we're going to call them form events, right? And these are other methods. These are reset calculator, filter operand, input, and apply operator. These are utility methods, right? That's what these are. And this thing right here, these are all other kinds of events. These are like kind of like UI control events. UI control events. All right, so any kind of UI control, like a button or a label or whatever, all the events would be here. I'm just separating this so we can kind of have some, kind of structure in our code. The other thing, this would be a constructor. We can make this. We can say these are constructors. We might have more than one. Right now, we only have one. That's calculator form. And here up here, we're going to have something that looks like public properties. We don't have private instance variables right now. We just have public properties, operand 1, operand 2. And do we really need them? That's the other question. Okay, but for now, we're going to use them. So, cool. So we have values. So when the form loads, operand 1 and operand 2 are equal to 0. 0.0 actually, because they're both doubles. It's going to run this reset calculator function. Okay, that's what it does. And then what we want to do is after the reset calculator has been kind of triggered, where we have my result labeled to 0, and we see this. It's all the way it looks on the actual result. This is the actual visual, and this is the back end. Operand 1 and operand 2 are both 0. Okay. But what about when this result comes into play? Well, we can test. We can say that, okay, if it's default, so that means some other button, this is some other operator has been clicked. We don't know which one, okay, right now. We just know that some other operator. We're not testing which one yet, right? But it's something else other than clear button or backspace. It's some other thing, okay? Then what we can say is that it doesn't matter which one it is. We want to convert operand 1 if we press any of them. We want to convert it into a double. All right, so we can say that if operand 1 is not 0.0, right? If operand 1, so first of all, is operand 1 even filled with anything, right? Like, we want to know which one to access. If operand 1 already has data and it's not 0.0, right? Then we want to add something to operand 2. Now, this is faulty thinking, but let's just put this in there. So we'll say operand 1. If operand 1, right, is we want to say it's something other than, it's not equal to 0.0. If it's not equal, something other than 0.0, right? Something else, right? Because 0.0 is the only case where it's kind of a reset. Then operand 2 is the thing that's going to be converted. Else, it's operand 1 that's going to be converted, right? So we're going to say, well, convert operand 1. So we're going to say result label.text. We want to take the result label.text and convert this result label.text to a double, right? So we're going to say convert dot to double, right? I want to convert to double this thing, and we're going to store this thing inside operand 2. Okay, if operand 1 is not equal to 0. Else, this is where we can do some kind of shortening here. It's the same thing, except it's operand 1. Now, we're going to convert something, but we don't know which one we're going to convert, right? So that's kind of a way of doing it. So it's like, which one is it? If it's operand not equal to 0, then we make operand 2. Otherwise, we make operand 1. Okay? And can we convert it? If operand 1, though, is not equal to 0, not only do we want to convert, but we want to calculate. So we also want to calculate or compute the operation. If it's not equal to 0, we want to convert it and then compute it, right? Because that's what we're going to do, right? Potentially. I'll say potentially. Because I can always backspace. I haven't done the compute yet, right? As an example, if I hit another operator again, right? If I've already converted, if I already have operand 2, right? As an example. So what about if that's the case? What about else if, what if operand 2 is not equal to 0? So operand 1 is equal to 0, but what about if in case where operand 2 is not also equal to 0? Well, you couldn't do it this way because it's not if this one or that one. If operand 1 is equal to something, right, then we want to do this case, right? If operand 1 is equal to something not equal to 0, then we want to, we want to convert it, right? As an example. So again, I'm just trying to think about how to put this in so we can kind of do this without any kind of recursive function, okay, as an example. So we're going to look at this and we'll say, okay, so which one are we going to do and what are the different cases? So what if operand 1 is not equal to 0.0, right? It means something else. Do we want to convert operand 2? Well, actually, if this is already converted, this is what this means is I'm already converted. I've already converted operand 1 to something else, which means I've already gone through this process once. That's what it does. What about if I already gone through and converted operand 2 to something else other than 0? Well, this actually should be first, operand 2, right? So if I did this already, it's more like, it should be like this. If operand 2 is not equal to 0.0, that means I've already got an operand 2. And if I'm getting back here with another operation, well, guess what? Here, I definitely want to do compute. I want to compute the operation. Here's where I want to compute the operation, if it's not equal to 0. Else if operand 1 is not equal to 0, then do this. Else if operand 1, if you haven't done anything, then do this. Not only do I want to compute the operation, right? But once I've computed the operation, I want to store that operation somewhere. And I need to store it inside of a result. Some kind of a result or a value or whatever you want to call it, because result label.text is going to continue to change. What if I want to do a chained operation afterwards? I want to take that result and store it potentially into operand 1 again, right? I want to say operand 1 is equal to that result, as an example, right? Because maybe I want to do that operation again. Okay, so depending on, it doesn't matter what I'm pressing right now, I'm converting. This is my conversion, right? So what I'm saying here in pseudocode is if any operator is pressed, right, then do this, right? That's what I'm saying. You do calculations before I even register which operator I'm doing. Doesn't matter which operator, right? Even if it's the equal sign, I want to do this, right? Okay, so far. All right, I'm converting. And what I want to do is test for this first. So I want to do a debug dot write line, and we'll say converted operand 2 with a result of whatever operand 2 is, right? We'll say plus, in this case, let's concatenate operand 2. And we're going to do the same thing with operand 1. So converted operand 1, and we're going to kind of show us what operand 1 is. I don't care about what the thing is. This is a mini step before we get into actually doing what we're supposed to do. All right, so here we are, and let's watch down there. So I'm pressing 7, right, as an example. Notice nothing's happened. But as soon as I press any of the operators, equals, plus, minus, any one of these, other than these two, let's say I press divide, right? It says converted operand 1, 7. So 7 has been converted, okay? And then I take operand 2, so I click another thing like this, and now we have a problem, 1.3. Now it's 71.3. I didn't clear my, it's not going to replace my operation. As soon as my operand, I should be able to take in a second operand, but I'm not doing that. I'm actually appending to this thing. So this is where I have an operation in progress. My operation is in progress. I'm actually making sure that the operation status is kind of in progress, if you will. Right? So calculator status is, operation, as an example. Calculator status is operand, right? Where I'm entering stuff in. If my calculator status is already in an operation, then if I already clicked that, then it should allow me to add, if I already clicked my operand and I've done this and I've converted once, then the next time I enter something in, I'm going to replace. The next time I enter something in. So I have to keep track of when that happens. So a good example of that is in my filter operand input, right? There's nothing in here that tells me that I should clear it if I've already got an operand, right? I've already got an operand, and then if operand 1 is already filled, then, well, you know what? If I press anything in here at all, then I'm going to replace. I'm going to start replacing my input with whatever I have here, right? Whatever I have here. So that's an interesting thing too. How do I do that? So here, it's just testing to see if my result label is equal to 0. Well, it wouldn't be at this point, right? I pressed my operation, and I'm still showing a result there right now. I'm still showing a result. I'm not making it 0 again. I'm not doing that. I'm not zeroing it out, right? But what I want to do is, as soon as I press another thing, if my operand is if my operand is equal to to something, my operand 1, then I want to make sure that my result text goes to 0. That's what I want. When I click on another button, it goes to 0, and then what I want to do is replace that with whatever I'm doing. Okay, so because again, I'm going to click that button, it's going to change to 0. So I'm going to say if, right up here, this is kind of an overseeing thing. If my operand 1 is not equal to 0.0, so if it's not empty, right, then what I want to do is I want to say that result text box, result label dot text, well, I want to make it equal to 0. I want to set it to 0 if my operand 1 is not equal to 0. So if I come in here and it's something else other than 0, I'm coming back and clicking on a number, then I'm going to change it to whatever it's going to be. It's going to be 0 again. So let's see if that works. It's going to actually not work exactly how you want. So 9, cool. I press minus, and then I press 6, and I can see that the 9 swapped out to 6, right? And then if I press times, you can see that operand 2 is equal to 6. All right? So now I should be calculating that result. If I press something else again, then it should say calculating result. And I can do that by up here where I say compute the operation. I'm going to put it in here for now, just some placeholder text that says computing operation. Right? So computing operation. Whatever the operation is. I don't know what the operation is going to be that, but this is the area that I'm going to compute the operation. Let's see if that works. Okay, so again, run it. So again, I select the number 2.3, and then I go plus. Notice it converts 2.3, and then 8.7. What happened there? Whoa, whoa. Okay, let's do that again. Clear. So 2.3 plus 8 dot, oh man, what happened there? Right? 8.7 minus, and I got like 7. So that was weird. That was a weird kind of sequence. Let's try that again. So again, 4 plus 8, right, equals, and I can say 4 and 8 are there. Operand 1, operator 2. But once I press that dot, remember we had some funny things with the dot operator that we did. And it kind of cleared stuff up. So let's try this again. So 8, again, 0.3 plus 5 equals. So we got 8.3 and 5, no problem. But it's when the second one has a decimal. So if I just went like 4 plus 1.2, then I'm not getting what I want. I'm getting 4 and 2, not 1.2. So why is that happening? All right. And if I press equal again, you can say some computing operation with 4 and 2. Right? So that's an issue, because it happens that we're following the cases here. So again, if the operand is not equal to 0, then we're making it so that it's operand 1. Then we're setting the result label.text to 0. Okay? And we're doing it again. We're going to do it again every single time I press a button, because this is for each button. For each button that, if operand 1 is not equal to 0, the second time I do it, right? So the reason why it worked for the first one is because operand 1 was equal to 0, right? So then this is ignored, right? But for the second operand, for the second time I went in, when I calculated it the second time, for each time it goes to this calculator button click, anything I click, it's going to say, well, let's make that 0, right? It's going to make it 0. So it has to be if the operand 1 is not equal to 0 and the result label.text, as an example, is also equal to 0. If both of those things are the case, right, then the result label text is equal to 0. That's the only time it's going to be 0. When both operand 1 and the result label text is already equal to 0. But that's going to stop us, because really what we're saying is that that's never going to trigger. because we had something in there before, and I don't want to, I don't have a value. So, again, let's think about what that is, like what I'm trying to do here, right? So result label.text, I got to check for something else. Like I'm coming back in here now, and yes, operand 1 is not equal to 0, but result label.text is equal to something else, and we're still working on the operation. The operation is still active somehow, right? We have an active operation happening, right? If it's an active operation, if it's already active, and I've already started entering my second operand, right? Then don't do this again. Don't clear it to 0 when I'm already starting to set up my second operand. So this is good, but it's bad. It only works in limited cases, right? It replaces the text when there's, when something's happening. And why? Because I'm going to come back here again. I'm going to come back to this round trip. So again, we have our result text as 0. And we also have this case where it's not 0. So here it's 0. Here it's not 0, right? And if it's already 0, then do this. If it's not 0, then replace it with a dot or something else, right? So that is where we're going to come back here and reset it to 0 again on the way back up. Because remember, this triggers every single time. It keeps triggering every single time that my operand 1 is not equal to 0, is not equal to 0, 0. So it's something that's in. We have something in operand 1. We're doing operand number 2. We want to clear the label, clear the result label.text. So that's what we want to do. We want to make it so that we want to do it once, but when we come back, right, we only want to do it for the first time we're inside. We've got some other value in there, right? So we want to say that result label.text cannot be 0 when we're doing this clearing. Okay? When we're doing this clearing, it cannot be 0, right? And we only want to check this once. We want to check this once. We don't want to keep doing this more than once. So we could do it here. We could do it here, or because this would be a bad place to do it. When I finish pressing operand 1, if operand 1 is entering something, if I'm converting, after I'm done converting operand 1, then what I could do is I could say that my result text box is equal to 0, but then I'm going to show 0 temporarily. Let's try that for now, and we'll fix it later. So we'll say my result label.text is equal to 0 here, right? So here's where my result text is equal to 0. So this is where I'm doing it. I'm only doing it once. I'm doing it in here. When my operand is not equal to 0, I'm making my result text, my result label equal to 0 as soon as I convert. Okay, so that means that how that works is if I go 9 plus, then it goes 0, 5, and then equals. And you can see 9 and 5 is good. And if I do something more complex, if I said something like 8.3 plus 5.6, then we're going to get 8.3 and 5.6 in there. My challenge is that we're showing the 0. So 8.3 plus, once I click plus, we see this is 0, and I don't want to see this as 0. I want to, in my mind, I know it's 0, but I want to show the new value. All right, so this is where we're going to fix it later. First make it work, then we'll fix it and make it nice. All right, so this is the calculation. Now, we don't know which calculator, which operation we're going to use to do here. We don't know which one it's going to be, right? In compute operation, we've got to flag an operation that's ready to be computed. We don't know what that is. So we press something, and whatever we've pressed, as soon as we go and press another operator again, any other operator, right? When operand 2 is not equal to 0, we want to do the computation. So it's like I want to do a switch case, right? And I want to do a switch case depending on which operator has been pressed. So here I'm going to say, let's do a switch case. So switch, another switch, inside the switch, I'm going to do another switch. And I'm going to say something like switch on my calculator button dot name. Again, second time. So first time we filtered, it's not the clear button or the backspace button. It's something else. That's what we know, right? And we can say that on calculator button name, let's suppose that the case is the plus button. So case plus button. Okay, that's one. Case if it's the minus button, because they're going to do different things, right? Case if it's the multiply button. I'm going to check to see what the button names are in a second. And case if it's the divide button. Okay? Let's see if that divide button. There we go. Okay. Divide. Woo! Divide button, multiply button. Let's check to see if those buttons exist. So we're going to see that this is the plus button, right? We can see this is the minus button. This is the multiply button. And this is the divide button. What about the equal button? This is the equals button. We have that case as well. What about that case? So case, what if it's that equals button thing? Equals button. Okay, so what if it's one of these, right? So plus, minus, multiply, divide, equals. It's one of these buttons. If it's the plus button, we want to store as the active operation is the plus button operation. We want to store this as the active operation. If it's the minus button, we want to store that as the active operation. So whatever the operation is, there's this, calculator button name. And depending on what the active operation is, we want to do this. We want to activate that particular event, right? We want to kind of go and trigger that kind of calculation, right? Well, we could do this, right? Or we could say something like when operand 2 is, whenever we get in here in the first place, we can say that the active operation, so let's say we have something up here, which is a string. We'll do a public property, right? We'll make it a string, and we'll say that it is the active operation, right? If the active operation, right, we'll say that active operation, right, is equal to the calculator button dot name. And in this case, we don't need to do any of this because we know now what the active operation is. Active operation, whatever the calculator button name is, we're good to go. Okay, so that's the active operation. Whatever we pressed last. Okay. So that's something to note. So we want to compute the active operation here, right? Compute the active operation. Depending on what that is, we're going to compute it. We're going to have one method to do that. We're going to store this method down here. We're going to make it private. We're going to make it void for now, and we're going to call it compute active operation. Okay, whatever the active operation is, we're going to do the computation here, right? So here's what we're going to call here, compute active operation, all right? We don't know what it is, but whatever it is, whatever the active operation is that we've got in here, when it comes to this point, we're going to compute it. And now, if depending on what it is, right, we can do that switch case. So let's do that switch again. We've kind of took care of that. So whatever the active operation is, now we can do that that case again, that switch case. And I'm just going to do it really quickly this time. Case plus button, right? And I'm just going to copy paste. So those are 4 cases. This is minus button, And by the way, these are just names. There's other ways we can do this with enums, but and divide. And there's one other case, which is the equals button. Okay, so depending on which one is here, then what we want to do is we want to say that the if it's one of these plus button, I want to do the calculation. I want to say that my result label or my result. So we don't have that. Let's put that in. So we have a operand 1, operand 2, active operation. We're going to say that the public or we'll do a property prop. We'll say results. Oops, double result, right? And again, we may not need this in a second, but the result is going to be the thing we want. We want to say the result is equal to, we're adding it together. So we're going to say operand 1 and then plus operand 2. Okay? Otherwise, what about if I have a minus? Then we operand 1 minus operand 2. Okay, what if I have a multiply? Operand 1 multiplied by operand 2. What if I have a divide? Uh-oh. Now we're going to get in some problems where if I divide by 0, then I'm going to have some checks to do here. I got to check to see if this is even possible that we can do. And what about if we have an equals button? If we have the equals button, then I want to take the result and convert it, right? So I want to convert the result into whatever it is. So I'm going to say if my result, right, as an example, is not equal to 0.0, then I want to convert it. I want to change my actually we should say not 0, but if the result is not equal to 0.0, then then and only then do I want to change my result text box, result label dot text. That's what my result text box is. I want to convert this to string. So I want to take my result dot toString and I want to convert it. And I convert it back so I can show it in my result text box, right? There's some limitations here. The other thing is that we should probably, when we're doing a reset, we should also not just change the operand 1 and operand 2 to 0, but we should change the results. Results should also be equal to 0.0 by default, and also the active operation should be equal to none. We don't have an active operation by default. We start off, we clear, there's no active operation, right? Because otherwise what's going to happen is if we ever go back, we're going to have to do this again. All right, let's try this again. So run it and see, do we get some simple calculations happening now, or do we have errors? So I said, 5 plus 5 is equal to, well, what happened to is equal to? It says computer operation, but okay. So let's see what happens. So I went 5 plus 5. I want to compute my active operation. Depending on what my active operation is, plus button, minus button, multiply button, divide button, and equals button. Let's see if we even get here. So we'll say debug dot writeline computing. So we know it's in here. Let's try that again. And let's see what happens. So I want to get, again, this is another way of tracing, right? So I want to say 7 plus 7, right? And then equals, and then look, it never got here. It never got to computing. 7 plus 7, and then I press equals, and then it didn't work. How about if I press plus? Okay, now it did it. Now I went to computing operation. Computing, it went to computing, right? But it never went to computing operation when I pressed equals, right? Not the first time anyway, right? So it says 14, see, and it doesn't do it over and over again. It just has that operation. Let's try that again. So 7 plus 7, and then equals, didn't do anything, but I pressed equals again. It doesn't really show anything. It's like it's broken, but if I press plus and then equals, then I'm good. So something is wrong. We're computing, but we're computing the wrong thing. All right. So if my result is not equal to 0, if that's what it says, if my equals button it's only going to convert this when my result is not equal to 0. Let's just take this check away for a second, right, to see what happens when it is equal to 0. And hopefully that's going to be what we want. Because maybe it's something else that's blocking us. Let's try that again. So again, it's, let's say 5 plus 5. We see that the result is there for us, equals, and then I got nothing. And now it's 0 again. All right, so that was weird. That was really, really weird that it did that. So what happens when you press the equals button? So this can be something that happened way down here. So compute active operation. This is if operand 2 is not equal to 0, right? And it's some other, the active operation is going to be equal to the name. So, okay, cool. So if we're here, if operand 2 is not equal to 0, right? That means I've already converted it. I've already got and done an operation. Oh, well, here you go, right? Operand 2, the only way it's not going to be equal to 0 is if I've already pressed equals, right? So if I've come in here and I've pressed equals the first time, right? If I pressed equals the first time, then it's considered an operation, right? My active operation is equal to equals. And let's print that out. Let's say whenever we go here, we'll do the active operation. So say debug.writeLine. We'll print out the active operation, whatever the active operation is, right? So we'll see what that looks like, because this is important too. Let's try it again. So 7 plus, so plus button is the active operation, right? 7, right? I press another button, but until I press one of these again, no calculation is going to be done. If I press equals, it says equals button is the active operation, right? Well, here is where we have to take our, the law into our hands. If I do something else, right now, if I press plus, right, then it's computing. It should be computing as soon as I press the equals button. As soon as I press the equals button, it should go to computing. Anytime I press the equals button. In fact, the equals button might be a special case, right? I want to just compute. Whatever I have, just compute it, right? So let's go and do that. So I'm going to say that, hey, if I come in here and if I press equals any time in here, then compute the active operation, whatever that is, right away. Go into this part right away, and don't do this. Don't do this part at all. If my active operation is this, right? So if I press equals any time, so example would be if I go here and I go 1, or if I go clear, if I go 1 equals, then I got 1. 1 is the result. If I press equals, that should be something I can do too, right? So 1 and equals. All right, so this is flawed, right? Because I can get here if the operand is equal to 0, or if my active operation is equal to equals, right? So we can say or active operation is equal to the equals button. If that's the case, right, I'm just going to put these kind of like in separated formats like this so we can see that separation. We don't have to do it this way, but I'm doing it anyway. So if operand 2 is not equal to 0 or active operation is equal to equals button, then compute the active operation, right? Whatever these two cases are. And if it's the equals button, then it's going to be here. It's going to see that it's my equals button and then get the result. Whatever the result label, whatever the result is currently, whatever's stored in the results, then output it, right? That's what I'm doing here. So either one or the other, right? So that's something that we have to think about. But what happens when if I press 1, I press the first operation, then I press equals. Well, then if I press 1 and I press equals, I'm going to do this, and 1 has never been converted. 1 has never been converted. So it's going to be actually 0, right? So if I did something like, if I did this now, and if I did, let's say 1 and then equals, it's going to be 0. Because that's what I told it to do. But if I said something like 1 plus 1, right, and then I press equals, well, that's also going to be equal to 0, right? Because of what I've told it to do. I don't get the result. Remember, the result doesn't happen until I have both operand 1 and operand 2 with a value, one or the other thing. So this is somewhat flawed. Okay. So what could I do? Because again, I'm going through this, so it's some operator that I'm hitting. I could do it also here. Instead of like my cases being in here, I could say that, well, whatever the active result, whatever's in the result label right now, convert it. Try and convert whatever's in the result right here, and then make that make that the thing. If it's here, I can just convert the result, whatever the result is, whatever's in operand 1 and operand 2, as an example. Do the active operation, whatever the active operation is. If the result is equal to the equals button, do the active operation, whatever that active operation is. So that's another thing I could do. I can make it so that it's different than this clear button or backspace button, and then I can have another one that says that's equals button, and the equals button will actually perform the active operation, whatever the active operation, calculate, which is this compute active operation. So it doesn't actually make the equals button an operation, it just computes it. And that might be a savior for us. So if I say something like this, case equals button, if it's the equals button, in this case, what we want to do is we want to compute the active operation. Whatever that is, right? Anytime we press the equals button. All right, so that's this. But the active operation has to be not none, right? Because here it could be none. I could not have pressed anything. I pressed 1 and equals. There is no active operation, right? And so because of that, the calculator button name could be also, the only time it's going to get in here is if it's not one of these three. It's not clear button, it's not backspace button, it's not the equals button. Well, it's some other button, right? And then I'm going to compute the active operation in here too, right? If it's something else, go back there and do the operation, kind of thing. But if I go here and compute the active operation as an example, and I haven't done any of these, then the if the active operation could be none, and if it's none, then what I want to do is I want to convert whatever I have already, in my if I don't have an active operation, let's go down to active operation. So the case could be none, right? So that could be the case. So I could have a default case. So default, if the case is none, so this would be case none, right? Then what that means is I want my result label.text to be, I want to convert my operand 1 as an example, because I've never pressed anything else. So whatever's inside of my result label, I want to convert it right away. So I want to say something like whatever's in operand 1, because if I press like 1 and then I press that, I want to convert operand 1 into a what it's going to be. So I'm going to say something like operand 1, right, is equal to, and I want to convert it from my result label.text, right? And so I'm going to convert to double, whatever it is, right? And what I want to do is, after I've converted it, I want to set the result. Instead of operand 1, I want to get the result. Even skip operand 1 altogether. Get the result to whatever that's inside the label, and that's what I want to hold in there. I want to hold the result to that, right? So the equals button here is something that never is going to get here now, right? We're never going to get this result label.text to string, right? If it's the equals button, right? Any operation should take us there. Result label.text to string should be any operation. So that means that anytime we get into here, after we've gone through this part, we're just going to calculate we're going to calculate, take the result label to text, whatever the string is, and convert it, whatever the case is, right? If that makes sense. So we don't need this. All right, let's try that out. So again, we have 2 plus 3 equals 2. Okay, that's wrong. So 2 plus 3 is equal to 2. So we press the equals button, and whatever was inside of the result label, we've got converted, right? Okay. How about if we said 2 plus 3 plus, right? So operand 1 is 2, operand 2 is 3, and then 3 plus, we did a computation, right? Whatever that computation is, we got 5. 2, you know, and that's, look at, now that's wrong, because now what's happening is it's not really adding our numbers up properly. It's going to continue to add into our thing. That's another flaw that we found in our code. So I'm going to end this now because we're running out of time. But what I want to talk about is this is how complex it can be to write a sequence, right, of operations the way we're writing it with if statements. So what is a better way to do this? And we're going to handle this. I'm going to give you the solution next week. But what would be a better way of doing this calculator as opposed to doing, you know, this if-else stuff? Because we're doing a lot of if-else, and there's a lot of situations where we can have multiple cases happening at the same time, right? So we want to do this compute operations. We want to compute something, right? We want to do this operand 1 and 2, right? If we're here, we're computing. We're already got something in operand 2. We're assuming that when we come to this point, operand 2 is filled with something. We're going to do the result. And at the end, we're going to take the result label and we're going to update it with whatever's inside the result. That's what we're going to do. Okay? Whenever we come to this compute active operation part. Okay? But somehow or another, our result is being lost. So one more thing before we go. Let's just print out the results. We'll say debug dot writeLine. We'll say result is, and then plus result, just so that we can see what the result is when we come to this point. Okay? One more time. So 2 plus 3 equals, and the result is 2. That doesn't make any sense, right? So that equals is broken. 2 plus 2 plus, well, the result, we never got to that somehow. 2 plus, and it's kind of like, well, result is 4, but we had to press 2 a bunch of times for it to get there. All right. Again, we want to make it, the reason why it's like this is because we want to make it so that we can do chained operations from the beginning. Not, as an example, just do 2 plus 2 and then calculate it, and that's it. I want to be able to do what the other calculator can do, what my calculator here. I'm trying to emulate this reference app that I'm using here. I'm trying to do what this does, right? Which is a lot harder than you think. All right, questions or comments? I'm open to questions and comments about this process, right? Again, think about what I'm doing. Switch case, is it the right solution for this particular user interface, right? And I've been focusing a lot on the back end today as opposed to the front end. The front end is this part. We've done this last day. The back end is this part, and we're trying to figure out the logic. Some of it works how we want, but some of it's not quite there, and it's not quite there because of our steps that we're taking. We're going through a sequence, and we're writing as we're going, right? We're not actually doing any kind of planning or anything like that. We're just going, and we're looking through this and saying, well, it could be 3 different cases: a clear button, a backspace button, or an equals button. Which one is it, as an example? And depending on which one we press, we want to hold on to this. Oh, this is maybe something that we don't want in here. How about that? Maybe that's probably what's causing some of the consternation. Let me just try that again. We forgot that part. So again, 2 plus 2 equals, and we should have a result. The result is 2 because we pressed equals, and that shouldn't be there. But 2 plus 2 plus, right? The result should be, 4, right? And we don't have that either. So we have to get that. The 4 comes, but it comes way after. So there's something else with this. We're almost there. We're just, our logic is slightly off, and we have to fix it. The other way to do this is with states. So I have a different kind of states for the calculator. My calculator could have a state where I'm in calculation mode, or I'm entering data mode, right? So I can shift from one to the other, and I can keep track of my states as opposed to keeping track of if statements, all right? Which button is being pressed and so on. So again, there's different approaches to this problem without using an evaluation string, without kind of doing an eval. And an eval, by the way, a lot of languages could just evaluate this. I can build up a big string, as an example, and then just say evaluate, and it'll evaluate the string with order of operations. Okay. All right. So I'm guessing there's no questions. I know it's hard to follow because it's me, coding, but you may have a challenge like this with your BMI calculator as well. It may not be as complex because the BMI calculator is really straightforward. You're just doing one calculation. You're not doing a string of calculations, but you may have to do a clear. You may have to do some of these other things that I'm showing you to do, and I'm trying to help you with your assignment. Okay? Okay, that's it for me, guys. I'm going to put this up on GitHub after I'm going to stop recording now and put it up on GitHub.